All right, welcome to the first video of the year. So just a heads up, this is going to be, as you've probably already seen, a lot longer than most of the videos, if not all the videos, will be in the future. And I don't want you to actually think that this will take longer. This video is kind of a setting of the table, so I'm going to reintroduce some topics that you are probably familiar with, but we want to make sure there's no ambiguity and no questions about them moving forward, particularly with this unit. And I'm going to talk about in a little bit more detail what I'm expecting that you do over the course of these videos. So the first thing I want to talk about is where these notes are going to go. So what you're going to do is you're going to save the first 3 pages in your notebook, first full 3 pages front and back, for your table of contents. Okay, and so the point of this table of contents is that, just to describe with an example, so on the first line of your first page of your table of contents, what you're going to do is you're going to write the first lesson. Or you don't have to use the PC there, but I just will for my own sake. Right? And then what you're going to do is you're going to write the aim for this particular lesson, right? Our aim is what we're going to accomplish in this lesson, right? And so I'm going to then fill in the aim on that first line here. And so I'm going to let you kind of think about what this means. You should be sort of familiar with it, and I'll let you kind of guess what maybe some of the extra letters that you see there mean. And you don't have to put in this first piece if you don't want to. If it takes too much space, your handwriting isn't, really small, whatever it is. And so you're going to write the aim here, use quadratic functions to answer questions about a problem in context, right? And if you need to shorten it up because it's too long and won't fit on one line, I trust that, as a senior in high school, you can synthesize a sentence fairly well. So you'll write out your aim here, and then the important piece, and the reason we have a table of contents, is so that we can actually write down the page number where you go to find that lesson. And so you would put page 1. And page 1, of course, is really the 4th page of your notebook. And so you'll go to the 4th page of your notebook. That's where you'll write your header, U1.01. You'll write the aim again. And so that way you'll know, yep, I found it, here I am. And so at the end of the year, when you are studying for the final and you're like, gosh, I really wish I could remember how to find the inverse of rational functions, or whatever it may be. And so you find, you're looking through your table of contents, you're like, I think that was like unit, 4 or something. And, you go through and you find like unit 4.07, that's the aim that you're looking for, and that's, maybe page, 107. Okay? And I encourage you to, if you feel comfortable with it, double side, so page 1 and then you flip the page over and that's page 2. You can do however you see fit, so long as you keep it, neat, whatever works for you. Okay? So as I said, today is going to be a little longer because I want to make sure we go through this process, and I'll kind of walk through some things a little more slowly as we go on with the video, but it shouldn't take any longer than a normal assignment. It's just that the video is going to be a little bit longer. All right, before we get started, I'm going to review some vocabulary that you may or may not be rusty on. Usually we will not start with vocabulary. That'll be something that we actually define after we discover it for the first time, but you should have already seen this before, so I just want to give you a quick refresher. The first is something called function notation, and to explain this, I'm going to just use a really simple example. So here you have an equation, y equals x minus 4, and so y depends on x, right? X is the independent variable. You plug in some value for x and subtract 4 from it, and that will give you your y value, right? Your dependent variable. And so what you can say is y is a function of whatever x is, or more simply, y is a function of x. And so we can write that f of x. And this is, you say f of x, this is not f times x, and this just means the same thing as the y value, but it's a way of representing that something is a function of another value, and so the y value is a function of whatever x is, okay? And so, if you plugged in some value, let's just write this out, so f of x is equal to x minus 4, right? And if you wanted to know what the value of this function was when x was 1, you'd say f of 1, and that would mean you'd plug in 1 for x, and so the value when f is 1 minus 4, which is negative 3. And so this is just, it really is another way of representing the y value. And so if you were to graph this function, you'd have your x-axis here, and you can, usually you'll represent the y-axis with a y, but if you're using function notation, you can just represent the y-axis as f of x, just like that. Okay, so it's very simple. All right, the next thing are something that you've seen before, certainly. Roots, x-intercepts, and zeros. They all mean the same thing, and they are the x values that make the y value 0. Okay, so for example, if I were to graph this function here, and I'll do that very quickly, it turns out that this function actually intersects the x-axis when x is 4. And of course, that value of 4 is what makes the y value, or the output, 0. Okay? A way of saying this in function notation is that the roots / x-intercepts / zeros are any x value or values that makes f of x equal to 0. So if we're going back to our example here, we want to know what the roots are. Well, we've got to set our function equal to 0. That will tell us what we have to do, what we have to make x so that our outcome is 0. And when we solve that, we'll get that x is equal to 4. Okay, and so that means that the root / x-intercept / 0 of our function is 4, and that's because if you were to plug in 4, the y value that you would get, the output, is 0. Okay, so now that we've got that, we should be ready to go. If any of this was a little confusing, maybe do a little more online research on roots and function notation, or stop by office hours. But I think you should be fine. Let's go ahead and get into some new material. So normally we'll begin a lesson with a think about a question, and the purpose of the think about a question is to give you the opportunity to discover the new something that we're going to learn on your own. Because when you discover something, you're going to learn it a lot better. And even if you don't discover it, right, if you fail in your attempt at discovering, it's actually going to help you learn it better when you finally figure out how to do it the right way. Okay? It's scientifically proven, and actually failing is one of the most important things that we're going to do, because we're going to learn a lot from making mistakes. So don't worry about messing up on these questions. The important part is that you give it a try. Okay, and that you try and implement some of the practices that we've talked about that make people successful, and some of the prior knowledge that you've seen before. Okay, it's going to help you to kind of just get used to finding new ways to do things and make you a much more successful just person in general. So a couple things to remind you of. Remember, we're going to make ourselves better problem solvers by following those 4 steps, right? Understand, plan, solve, and check. So for any question that we answer, you're going to want to just write UPSC, and you're going to want to check off when you've completed your understanding, when you've got a plan, when you've solved, when you've checked, so on and so forth. Sometimes you might actually want to write out your plan or make annotations for your understanding, or write out exactly what you're trying to find. And sometimes you can just do it in your head, and when you've got it, you can check it off and move on. And the last thing is to remember those 8 characteristics that successful mathematicians have. And I want to call special attention to number 1, which is to make sense, or persevere in solving problems. And that's going to be really helpful. So don't give up if the first time it doesn't work out so well. Maybe try another time, or maybe even 2 more times, because learning from your mistakes and then persevering and trying to find an answer is ultimately what's going to make you successful, right? It's really easy to give up. That's why successful people are not all over the place, right? It takes a special type of person to not give up. So give these your best effort. Spend at least 5 minutes on these, and so that you're giving yourself ample opportunity. And then press play, and we'll kind of talk about them a little bit. One important thing is that you need to try these. And so what you'll do is you'll try these on your own. You'll copy down the problem. You'll try them on your own. And then you'll press play. and I may, go through the problem and make some corrections. And so what you'll want to do is draw a line underneath where you did your attempt, and there underneath the line you can make any corrections or fill in the correct solution, so that when you're going back and you're looking and studying, you can actually say, okay, I made a mistake here, right? But here's the correct way of doing it, and you can learn a little better that way. So give it a try, and in about 5 minutes, go ahead and press play, and we'll discuss a little bit. All right, we're going to go through these pretty quickly. So finding the roots means that we're trying to find the x values that make the function equal to 0. It's our understanding piece, and our plan should be, at least at the beginning for number 1, set our function equal to 0 and solve for x. So applying that on the first function, we'll set it equal to 0 and we'll solve. And how will you solve this? Well, this is pretty simple, right? I'm going to use inverse operations, subtract 4, divide by 2, and I'm going to arrive at an answer of x equals -2. And so that's my root for that first function. Now for my second function, I notice that this is slightly different, right? Here I had x to the first power, a linear function, right, a straight line, and here I have a quadratic, right, x squared. And so, look, I can't quite apply my ability of solving linear functions to this because right now I have a quadratic. So what we want to think about is how can we make this look at least a little bit more like this? And we can think back to factoring, right? We know that if we have something that's x squared, well, what got me x squared? Well, you had to multiply x times x. In other words, you have to have two factors, both with an x to the first power, in order to get this quadratic. And so we can factor this into two pieces that will multiply by each other, and each of them has to start off with x, because x times x is x squared. So we'll have x times x, and then, right, we're going to have to get this other piece somehow, so we're going to have plus or minus something and plus or minus something. And remember, by thinking about foiling, right, that these last two pieces, this plus or minus something times this plus or minus something, will get you x, and then you're going to multiply each of these last pieces as well by the x in the other factor, and so then you'll add them together because they have a common x, and you'll have to get 5x. So what can you multiply to get 6 and add to get 5? Well, you have 1 and 6, 2 and 3, -1 and -6, and -2 and -3, and only +2 and +3 will get the job done. So +2 and +3. And what you want to do is find out when this is equal to 0. And so here, this is now much simpler because both of these pieces here are linear, right? And they're easy to solve with inverse operations. And you're multiplying them by each other, and they have to equal 0. So let's just think about this. What do you, when you multiply two things together and they equal 0, what has to be true about one of those two things? Well, one of them has to be equal to 0. That's the only way you can end up getting 0 from multiplication. And so it boils down to two options. Either x plus 2 equals 0 or x plus 3 equals 0. So you'll set those up and solve each of them, right? X plus 2 equals 0. I'll just do 1. X plus 2 equals 0. So x is equal to -2. And when I solve the other one, I'm going to end up getting that x has to be equal to -3. So I have two options. The roots are x equals -2 and x equals -3. Now moving on to the third one, we have another situation where we have a quadratic, but here this does not look like something I want to factor, right? What do I multiply to get 35.2? I mean, it looks really like a pain. So how can we apply some of the strategies we've used previously to try and find the x value that will make the whole thing equal to 0? And we might want to go back to our original function. And remember that we used inverse operations here. And maybe we can apply inverse operations to solve this here. So we set it equal to 0, and we'd want to apply inverse operations to solve this here. And so what I want you to do is I want to encourage you right now to go ahead and try doing that on your own. Okay? So try and solve for x there. Now, hopefully you gave that a try, and my guess is you probably didn't get a whole long way down the road, right? There was probably a point where you ran into a situation where you're like, I just don't know what to do. And this is not a fun place to be, right? We'd like to know what to do in order to solve a quadratic equation when it's set equal to 0, right? That would be very helpful to solve this question. And so what we need to do is figure out a way to solve a quadratic when we can't factor it very easily, and we need to be able to find an x value that will make it 0. And so that's what we're going to go ahead and do in this lesson. So let's go ahead and try and find a way to do this. So what we've kind of run into is a situation where we need a method for solving any quadratic function regardless of what the coefficients are, right? Regardless of whether we can factor it easily or not. And so what we need to do is first be able to look at a quadratic function that could be any quadratic function. And what I mean by that is writing a quadratic function in this form. F of x is equal to ax squared plus bx plus c. And you'll notice here that I've represented the coefficients as variables, a, b, and c. But what they're just standing in for is whatever the coefficients might be. And since we're representing them as a, b, and c as variables, what we're doing is we're acknowledging the fact that, look, they could be any value, right? They could be negative 16, 2, and negative 43, right? It doesn't matter what they are. We're going to solve this equation, set it equal to 0, and solve, and see that there's a function, not a function, but an equation that will allow us to solve for any set of coefficients that we might come across. So let's go ahead and give this a try. Now what I want to do is let you know that some of the techniques that we're going to use to find the roots of this generic quadratic function, they might seem complicated and tricky, and if you don't understand exactly how to do every single move, that's okay. But we want to have a general idea of how it is that we can find the roots to any quadratic function, and that's what's really important. So do your best to follow along. I encourage you to try and think about what the next step might be. So pausing the video and giving yourself maybe 10-15 seconds to just kind of think about what you might do will really benefit you in the long run. All right, so the first thing is just to remind ourselves again what it is we're trying to figure out, and that is to find the roots. And so finding the roots means that we want to know when this function will be equal to 0. So we set it equal to 0, and now our goal is to solve for x now that it's been set to 0. So let's go ahead and I'm going to rewrite this portion of the equation so that we can start working on it. Right. The first thing we have to do is come up with at least some sort of game plan for how this is going to happen. And if you think back to the quadratic that we were able to solve it by factoring. And in order to factor, at least easily factor, it would be really helpful if we didn't have a coefficient with our x squared term. Because if the coefficient is just 1, in other words, we don't have this a here, it's just 1 x squared, then we know that the factors will be x plus or minus something times x plus or minus something. And that at least is a start. So in order to do that, we need to divide out this a here. So we're going to divide by a on both sides. And remember, when I divide on both sides, that means I have to divide each part of each side by a. And so as I work through here, a over a is 1 over 1, b over a, c over a, and 0 over a. 0 divided by anything is just 0. Okay? So I can rewrite my equation as x squared plus b over a times x plus c over a. And that is all equal to 0. Okay, great. Now I need to think about how am I going to factor this. And what we realize is that, look, if we're going to factor this into two factors, we would need something that would multiply to be c over a and add to be b over a. And you should be a little worried about that because b and c, we don't know what those are. So that's going to be a little complicated. It would be nice if we could have something over here that we knew how it related to b over a. So why don't we just get rid of c over a? In other words, let's get rid of it on the left side and it'll end up on the right side. And then we can just kind of play around with what we have left over. So we'll subtract c minus a from both sides. And when I do that, I end up with negative c over a on the right. And on the left side, I have x squared plus b over a times x. And purposely, I'm leaving us a little space over here because now we're in pretty good shape to think about what we'll need to do in order to factor the left side of our equation. And in order to think about this, let's remember the basics that we talked about, right? X squared. How do I end up with x squared? Well, I multiply x times x to the first times x to the first. So essentially what I know is that I'm going to have these two, and I'll write these in green here. I'm going to have these two factors that I'm going to multiply by each other. And I know that each of them are going to have an x to the first term, right? Because x times x is x squared. And so now we can use our knowledge of the multiplication of these pieces right here, right? The kind of the remaining, the missing link. And we know that, I'm just going to put a little blank here. We know that when we multiply this times this, we'll get whatever this kind of missing value is, right? And when we add these two together, we'll have to end up with b over a. And so let's think about, okay, what could you add together to get b over a? And to make this a little easier, imagine b over a was just the number 10. What immediately comes to mind that you could add together to get 10? And you probably said 5 and 5. How did you come up with that? Well, you took 10 and you divided it by 2. And then you add those things together and you get 10. So let's take b over a and divide it by 2. Another way of doing that is multiplying by 1/2. So we'd have b over 2a. And that is going to be the missing piece. b over 2a. Okay? And since this missing piece is b over 2a, when we multiply b over 2a times b over 2a, we're going to get b over 2a squared, right? Something times itself is that something squared. So the missing piece that we'll have to add to both sides of our equation is b over 2a squared. Okay. Now, before I bring the right side down, we can actually do some simplification. And this simplification might seem a little, complex, but it's really not. So just do your best to follow along. The first thing that I realized, I'll rewrite this portion in green here, is we have b squared over 2a squared. And when I square 2a, that's 2a times 2a, and that's 4a squared. So this piece here is really just b squared over 4a squared. And now what I have is c minus c over a plus b squared over 4a squared. And really those are just fractions. And remind yourself, if you want to add two fractions, what do you need to do? Well, you need to get a common denominator. And so I see that I already have an a in the denominator here, and I have an a in the denominator here. I just have 4a squared. So to make the denominators the same, I just have to multiply negative c over a by 4a in the numerator and the denominator, by 4a. And when I do that, what I will end up with is negative 4ac all over 4a squared. And when I look at this here, I have the same denominator, so all I do is now add the numerators. Well, it'll be negative 4ac plus b squared. I can just rewrite that as the positive value first, so b squared minus 4ac. All over 4a squared. And at this point, you may start to notice that this looks a little familiar, if you can think all the way back to Algebra 1. Okay, so the next thing for us to notice is look at the left side here. Not only have we sort of gotten rid of this quadratic situation that was causing us problems, but we created something that was really helpful, and that is that we have something times itself. When we have something times itself, it's that something squared. So we can rewrite this as x plus b over 2a all squared, and that is equal to b squared minus 4ac over 4a squared. Okay, and we're almost there. To help us with this next step, I want you to consider what you would do to solve this equation. I'm just going to write it down here below as kind of a thought bubble. Imagine you had x squared equals 4. How would you solve that? Well, you'd think about, okay, what would I multiply by itself to get 4? In other words, I would square root both sides, because I would want to know what is the square root of 4. In other words, what do I multiply by itself to get 4? And that value is 2. And so I would end up with x is equal to 2. And so I can apply the same thing here, right? If I'm squaring something, the inverse operation of squaring is square rooting. So I can square root both sides. Okay? And now I'm going to bring this piece up here to the right to give me a little more space. And if we look at the left side, imagine, okay, I have something, I'm squaring it, and then I'm square rooting it. What am I left with? Just what I had originally. To help you understand that, imagine you took the square root of 2 squared. Well, 2 squared is 4, square root it, you're back to 2, right? So I'm left with x plus b over 2a on the left. And on the right, it seems like I have just the square root of whatever this is. But there's one more thing that we have to notice. And to help us understand this, go back to this sample problem, kind of the example thought bubble that we had over here. Is 2 the only thing that I could square to get 4? In other words, is the only solution to this 2? And that's not quite the case, because when you're squaring something, you're multiplying it by itself. So 2 times 2 is 4, but so is negative 2 times negative 2, because a negative times a negative is a positive. And so when we square root something, we have to consider both the positive and the negative values. Okay? And so we have to include a plus or minus. So we have that this is equal to plus or minus, either one will work. And when we're square rooting a fraction, we can square root the numerator and the denominator separately. So let's square root the top. B squared minus 4ac. And let's square root the denominator. The square root of 4a squared. Okay, well, almost there. One thing to notice is that in our denominator, we're square rooting 4 times a squared. And we can square root, if we're multiplying two things and square rooting them, we can actually square root them separately. So we could do the square root of 4 times the square root of a squared. Well, the square root of 4 is 2, and the square root of a squared is a. So really, I'm just left with 2a. The square root of 4a squared is 2a. Okay? So, make sure I get that out of the way there. The denominator is 2a. I'm very, very close. I have x here, and remember my goal, if I think back to my original situation here, I needed to solve for the x value that would make this whole equation equal to 0. And I'm very, very close, right? I set it equal to 0, and I am almost at the point where x is going to be isolated in my equation. All I have to do is subtract b over 2a from both sides. Okay? So I'm going to subtract b over 2a from both sides. So minus b over 2a, and over here, minus b over 2a. And of course, those will cancel here. And so on the left side, I'm left with x. And here I'm finally going to not line up my equal signs, simply so that I have enough room on the right side. I have that x is equal to, and let's just write the negative b over 2a first, and then the plus or minus this piece here. So I have negative b over 2a plus or minus, and I have the square root of b squared minus 4ac all over 2a. And at this point, we've solved it, right? We have what the x value is that will make our function equal to 0. And you'll notice that there are actually two roots, right? I could have negative b over 2a plus whatever this is, or I could have negative b over 2a minus whatever this is. And that should make sense from what you've learned about quadratic functions. And you'll also notice is that this here, negative b over 2a, is actually the x value where the vertex occurs, where the minimum or maximum occurs. And that should also make sense because if you think about a quadratic, the roots are the same distance away from your maximum or minimum, right? It's symmetric. And that should make sense because here you're either adding or subtracting the same amount from wherever your vertex is. So this is a really helpful way of seeing the very cool relationships that quadratic functions have with their roots and their vertices, their vertex. But you can actually simplify this a little more because both of these have the same denominator here. So what you really have is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, but either way will work just fine, but we'll go ahead and clean it up just to make it a little more neat. So my final solution is that x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And this is the x value, or values, because there's going to be two of them in almost all cases. This is the x value that solves for the roots, right? These are the roots, the x-intercepts or the zeros. And so whenever I have a situation where I'm setting a quadratic function equal to 0, or trying to find the roots, the x value I'm looking for will be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And I just want to make sure this whole thing is being square rooted. There you go. And this should seem very familiar. This is, of course, known as the quadratic formula. And the quadratic formula is incredibly useful because whenever I have a quadratic function and I want to know the roots, x-intercepts, or zeros, whatever you want to call them, I set my equation equal to 0, and instead of going through this whole process every time, I can go ahead and skip ahead to the end and say, look, no matter what a, b, and c are, I know that the x value that solves this equation, that makes it equal to 0, that x value or x values is equal to this piece right here. Okay? So look, this was a long video. I totally understand most of them won't be anywhere near this long and will actually kind of be a little different, but we wanted to get off on the right foot and make sure that this stuff was fresh in our minds so that we could be really successful in this unit. So pat yourself on the back for having derived the quadratic formula, and be ready to utilize it to solve real-world questions when we meet again.